everyone. Welcome to our last training of our bioaccumulation monitoring training series for 2024. I'm Anna Holder. I'll be a part of your MC today, but I'm going to pass it off to Wesley Smith and Lauren Chumney, who are going to talk to us today about OEHHA fish advisories. So take it away, y'all.
Thanks, Anna. So my name is Wes Smith. I'm the senior toxicologist at the Fish Ecotoxicology and Water section. It's listed here. We work on fish advisories, oil spills, and harmful algal blooms. And I'm also joined by Lauren Chumney today, and I'll let Lauren introduce herself.
Hi, everybody. I'm a senior environmental scientist in Wes's group and one of the lead authors for fish advisory development.
And thanks, Lauren. And we also have a guest speaker today, our star of the show, Sherry Norris. She'll be presenting a few slides. So if you just want to introduce yourself, Sherry.
Hi, my name is Sherry Norris. I'm with the California Indian Environmental Alliance, and I'm glad that you made it today. Good morning.
Great. Thank you, Sherry. Now, since we have a lot of stuff to cover today, I guess we'll get started. So here's just a general overview, and these times are probably a little over what we'll be taking just to allow room for questions, but we'll start with a general overview of fish advisories. We'll do a review of sampling and analysis for fish advisories. This topic was covered earlier in the year, but we figure it's important to go through it again because it is the basis for our advisories. We'll also cover data evaluation and the prioritization process, allow some time for questions and discussion, take a short break, and then move on to how we develop our advisory tissue levels, which may include a bit of math, but we'll try to walk you through it step by step to make it understandable. And then we'll close with questions and discussion, and then turn it back to Anna for next steps. So we want to start off we have some virtual engagement tools by utilizing Zoom polls. So we'll ask a question and then a poll box will pop up on your screen. You can submit your response and then press submit, and then Anna will share the results and we can discuss them together. So for our first poll, we're curious if you've ever used a OEHHA fish advisory to decide which fish and what quantity of those fish you'd consume from a water body.
So the poll should be up on your screen. I added an unsure just because when I was creating this poll this morning, I hadn't had my coffee and I didn't know what was happening in my life. So I added unsure just in case. But it looks like we've got small but mighty group, and almost everyone has participated. So I'll give it another couple of seconds and then we'll end the poll and share the results. So the results should pop up on your screen. I'm going to talk through them because you can't see it on the recording. So everyone who responded said that they haven't used OEHHA fish advisories. So that's great. We're so glad you're here. This is perfect. Yeah. Okay.
Great. Yeah, have plenty of information to learn all about the advisories. So just to give you a little background on who the Office of Environmental Health Hazard Assessment is, we're the lead state agency to assess health risks to humans from environmental contaminants, the most of which are chemicals produced by humans, but we also assess naturally occurring elements generally. We develop health protective guidance values for drinking water, air, soil, and other media, provide toxicological expertise to other state agencies. We're located within Cal EPA, but we also work with other agencies such as Department of Fish and Wildlife and Department of Public Health. And we also do a lot of internal training and educational work on using and developing scientific knowledge to better understand the risks of exposure to toxic substances. And on the right, you can just see some of the programs that OEHHA, that are housed at OEHHA. So for our fish advisory overview, just a brief background of what fish advisories are. These apply to non-commercially caught fish. So most of advice for commercially caught fish is handled by the Food and Drug Administration. So this is subsistence fish within the state, recreationally caught fish, or fish caught for cultural uses. And these are for water bodies within California, including state waters of the Pacific Ocean, which is 3 nautical miles offshore, and surrounding islands within the state. So the fish advisories provide recommendations on how much fish to eat over the course of a week, from 0 meals per week to 7 meals per week. They're based on the chemical contaminants in fish and shellfish. And we are currently looking at science and updating to use the best available science to balance the benefits and risks of eating fish. A lot of programs at OEHHA only look at the risks. We're unique in the fact that we look at the benefits, since we are discussing and working on something that people eat. And they're based on data review and professional judgment. So another Zoom poll. So of the chemicals below, which would you be most concerned about in fish? So we have
Sorry, we're having a user error on my part here. 1 second.
Some of these chemicals are the most commonly found in fish. You probably recognize them. They're pretty common bad actors in the news, and information about negative health consequences from these chemicals that last a long time and build up in fish and other biota.
I missed this one, so I'm writing it right now.
Good thing Anna is a Zoom wizard and can put this stuff together really quick.
But the spelling is going to be wrong.
We know what you mean.
PCBs. And oh, dang it. And there. Okay. There's save as meeting. My goodness. Y'all, I'm so sorry about this. There's going to be a weird question that's not a real question, so you can just ignore it because I pressed the wrong button. So, okay, the poll should have just launched, and so a screen should pop up. Oh, and I think I might have only allowed single choice. So that's, again, my bad. So pick the one that you're most concerned about, and then if there are multiples, which y'all are pros, already adding stuff in the chat. So we've got some all of the above, plus PFAS, 6 PPD, quinone. Great. So we'll give another couple of seconds just to tell us about the one pollutant that you're most concerned about, because I failed at the poll this morning. I'm so sorry. But we can have a broader conversation about that.
Yeah, we obviously have some informed folks here if we're adding 6 PPD, quinone, and
Okay. I'll end the poll really quickly and share the results. And it looks like for the people that were able to complete the poll, the the chemical that they're most concerned about is mercury. Same.
And that's a good choice because mercury is one of the most common contaminants in California fish. So moving on, this is the list of chemicals that we have developed by our advisory tissue levels for, and that advisories may be based on. Mercury, as many of you are well aware, also selenium tends to be high in some fish in Southern California. And the interesting part is selenium is required by the body for functioning, but too much can be toxic. Then we have our two industrial chemicals, PCBs and polybrominated diphenyl ethers, or PBDEs, which are flame retardants. Thankfully, most of these compounds are no longer used, but since they last a long time, they're still found. And there are some PBDEs that are still used, but hopefully they're a little less persistent. And then legacy pesticides, all of which are banned, but again, they tend to be persistent and last in the environment. DDTs, dieldrin, chlordane, and toxaphene. And you'll see these chemicals or this slide flashed up multiple times just because it serves as the basis of a lot of the work we do. So as far as current fish consumption advisories, in the table to the left, we have the risk driver, and that's the chemical that results in the lowest amount of servings per week. And then on the right, we have the percent of advisories. And as you can see, mercury occupies almost 100% of all advisories, with PCBs being a distant second at around 40%, and then selenium dropping down to 8%, and then a handful of others. And some people ask us, why doesn't this equal 100%? And that's because there are multiple species in each advisory, and those species can accumulate different types of contaminants. So these numbers are of 100% of total advisories. And then to the right is a map of all our site-specific advisories. So you can see there's a lot in Northern California and Southern California, with some gaps in between, and that can be due to a number of reasons, such as lack of water bodies or different geographies and sampling resources. Another common aspect to our advisories is that we issue guidelines for two populations, one being women of 18 to 49 years of age and children from 1 to 17 years of age. And we term this as the sensitive population, and this is due to increased sensitivity to mercury for developing fetus and young children. And then the rest of the population, women 50 years and older and men 18 years and older, who are typically less sensitive to the effects of mercury, and we term that as the general population. And just as a caveat, that women 18 to 49 years aren't necessarily more susceptible to mercury. It's just the potential effects to the fetus if a woman is pregnant. It's an important thing to keep in mind. So I just want to give you a brief overview of our advisories. Again, on the upper left of the poster, you can see the two populations, the sensitive population and the general population. Moving down from there are the servings per week for that population. And then if you move across, you can see the different species that fall within that category. So you can do it one of two ways: find your population and how many times you'd like to consume fish for a particular week, or you can look on the right and just identify which species you'd like to eat. And then above that, we have the title for the advisory. This is a recent advisory for Lake Berryessa. Just some general information below that on why fish are healthy. And then beside that to the right, what are the negative aspects to the chemicals within fish. This advisory is based on mercury, which can harm the brain and nervous system, especially in fetuses, babies, and children. Moving down to the lower right, we have our recommended serving size, which is 8 ounces for adults and less than for younger children, generally about the size and thickness of your palm. And this is for uncooked fish. To the right, we have contact information, And then just some general advice. We generally advise the folks to only eat the skinless fillet, and I'll describe why later. And also eating only the meat of shellfish, and that has to do with the concentration of biotoxins from harmful algal blooms in the viscera. And then we have a QR code to the right, which will bring you to the landing page for the advisory, which has additional information. So that's something we're hoping to continue to build out to provide more information. So we have two types of advisories, one being site specific, and we're at 145 and counting. And we generally produce 9 to 12 advisories a year. And these are for individual water bodies, and they typically require 3 species and 9 fish per species, so we get a good sample size. We only use fish that are legal size to take, or if there is no legal limit, the adult size of the species, which is referred to as the length at maturity. And we use an average for each species, which is an arithmetic mean concentration, to compare to our advisory tissue levels, but we also consider the range of concentrations when deciding on final advice. And then we also have statewide advisories. So I'll go through each of these individually. So for our advisory from lakes and reservoirs, this is to cover water bodies throughout the state without site-specific advisory until we are able to develop a site-specific advisory. And this included over 8,000 fish for mercury, greater than 4,000 fish for PCBs. We included species with more than 100 samples for mercury, or from 50 lakes, unless certain species has a limited biogeographic distribution, such as certain types of trout, which might be only in alpine lakes or similar situations. And it used data from 30 studies and provides advice for 14 species or species groups. And species groups are usually groups of fish that have similar diets and accumulate similar levels of contaminants. And these are based on the 90th percentile value, which means we're not looking at the average, but kind of a higher end estimation. And that's because we want to be more health protected, because they are covering such a wide range. And then for rivers, streams, and creeks, we use data from 700 unique locations throughout the state, and again, around 7,500 fish for mercury, 1,100 for PCBs. PCBs tend not to accumulate as much in rivers on a general statement, or we have less data. There's kind of a mix of reasons. And again, we included species with greater than 100 samples for mercury and across 5 regional boards, and used data from approximately 15 studies, and again, used the 90th percentile to develop the advice. We also have advice for the coast. We call it our coastal advisory. And this applies to all coastal locations, excluding enclosed bays and areas with existing advisories, such as Tamales Bay, San Francisco Bay, Humboldt Bay, San Diego Bay, Mission Bay, or just some of the areas that are excluded. And because it is such a wide area, we use data from at least 30 individuals per species from at least 3 locations. There are some minor exceptions. And we evaluated 300 fish across 33 different species. And for this advisory, we did use the mean rather than the 90th percentile, and that's because these are all within the same water body and generally share similar concentrations of contaminants. There are some differences across, but we took those into account as we developed the advice. And then we also have an advisory for anadromous species, or fish that migrate. So you might be familiar with salmon, white sturgeon, and some of the other species, steelhead, that move from the ocean back to the rivers to spawn. And it's primarily the San Francisco, San Joaquin Delta, or Sacramento, San Joaquin Delta, San Francisco Bay, the coast around San Francisco, as well as Central Valley rivers in the Delta. So this advisory included data for 600 fish. The data was from 10 studies, and we used the 90th percentile of the mean for this advisory. And it applies to all water bodies where these species are found, except for the lakes and reservoirs where there are isolated populations of some of these species. So I just wanted to do, this is an image of our website, and I just wanted to do a quick walkthrough to get you more familiar with our website in case you want to get more information on your own. This is our fish advisory landing page. We have information about the two populations. General information, there's a fact sheet about the advisories, information on how to follow advisories, more specific information for women and children, and then general tips. We have our statewide advisories. And then we also have a searchable database where advisories can be searched by the water body name, county, or species. So that can be a convenient way to find information you might be interested in. We also have an advisory map, which hopefully my computer's fast enough, which shows you where we have advisories for. These blue markers are for lakes and reservoirs.
Hey, Wes,
Yeah.
I'm not seeing your demo. I just see the slide.
Oh, all right. Thank you. It is a sharing thing. So here's our map.
Got
You
it.
see it now. Thanks, Anna. And so these blue markers are lakes, and the orange markers are river, streams, and creeks. So you can click on these and go to a specific water body landing page where you can see what the advisory is based on. We have posters for the advisories, fact sheets, and reports. The technical report that has all the information of how the advisory was developed. And on each page shows what the advice is. So I'll go back to where I started because no one saw that. So this is our fish advisory landing page, and we just have general information, advice about the two populations, fact sheets about the advisories in different languages, how to follow advisories, specific advice for women and children, general tips, or statewide advisories. And then we have a searchable database that you can search by water body, by county, if you want to look for locations, or by species, if you are trying to find different water bodies with these species. And in addition to that, we also have our main page, which has information on the benefits and risks of eating fish, a page that discusses our oil spills and seafood safety program, another page with technical documents, and at this location houses our advisory tissue level reports, which I'll be talking about later. Some of the information that Lauren will be presenting on the prioritization process, and also our sampling analysis, as well as a few other reports. We have another page that discusses domoic acid. This is a marine biotoxin that can cause amnesic shellfish poisoning and tends to occur in razor clams and crustaceans such as Dungeness crabs, spiny lobster, and rock crab. Something that's good to be aware of. Then we have additional translations, education outreach materials, and that's a quick overview of our website. So I'll go back and share the presentation. And before I move on, I'll stop to see if there's any questions.
There's enough of us. That's not proper grammar. Feel free to unmute yourself and just chime in or add something to the chat. Or raise your hand if that feels more comfortable for you.
I'll add a little thing. This is Sherry. One of the reasons why that we look at in the fish consumption advisories, the red, yellow, green, and then why we talk about meals per week, is in part because of the participation of communities and tribes when these advisories were first being created for mercury. We had tons of focus groups, and the red, yellow, green of people's lights as they drive made the most sense. And then per week, because we're talking about the developing fetus being the most at risk. And if the cell is developing at that moment, we don't want to wait and let you build up your entire set of toxins for a month. We'd rather that you got a little more specific on what you're eating in a week. So that's why those advisories. So there's also the parts on the children's amounts being smaller. It's because they are more at risk. So having a smaller amount in their hand, when you do the comparison, is more applicable, more appropriate for what they really should be eating. But yeah, thank you.
Yeah.
Thanks,
Thank
guys.
you for that, Sherry. That's a really good point. There's some states that offer mercury advice on a monthly basis, but we choose to only do it on a weekly basis for the reasons Sherry mentioned. All right, so I'll turn it over to Lauren to present the next two sections.
All right, thanks, Wes. All right, so hi, everybody. I'll be giving an overview of our general fish advisory development process, and I'll discuss each one of the steps shown here, along with how we prioritize our water bodies for advisory development. So this graphic shows our general process. Sample collection and analysis is under the purview of the Water Board Swamp Program, and OEHHA downloads the data that they generate. We analyze and interpret them, and we develop the advisory materials. And as I get started, I'll just say, if anybody has any questions while I'm talking, feel free to raise your hand. We will have time at the very end for any discussion. So the first step of development is to collect the fish. A monitoring plan is developed by the Safe to Eat work group, which operates within the SWAMP program and is open to anyone who's interested in bioaccumulation. They consult with staff at OEHHA along with other entities for input on where to sample, what species to collect, what analyze to test for. And samples may also be collected outside the SWAMP program, such as by water utilities for FERC relicensing requirements or by other governmental or non-governmental organizations. A little lag there. Once the fish are collected, they'll go off for analysis. Samples collected by the swamp are generally analyzed at Moss Landing Marine Laboratories. Samples collected by other organizations and studies may be analyzed at other certified laboratories. After the data are analyzed and checked for accuracy, they're entered into the California Environmental Data Exchange Network, or CEDN, which is the Water Board's statewide repository for surface water quality data in California. Ideally, all applicable data, even those collected by entities outside of the SWAMP program, will enter their data into CEDN. These data are available online to anyone and used for a variety of statewide management efforts, including fish advisories. So after we obtain all known data for a water body, we'll evaluate them by several criteria that I'll describe more in detail later. The data that do meet our criteria are included in a data set, which is used to determine the tissue concentration of each chemical that was analyzed for each species. And those concentrations are then compared to our advisory tissue levels, or ATLs, which are chemical concentrations in fish tissue that are considered safe based on consumption rates. They provide 0 to 7 recommended 8-ounce servings per week based on the range of contaminant concentrations that are found in fish. And our ATLs were developed to include the health benefits associated with eating fish. They're not a strict criterion upon which we determine advice, as Wes mentioned earlier. We use them in tandem with a holistic view of the data and our best scientific judgment. The ATLs can be based on cancer or non-cancer health effects, And in the last part of our presentation today, Wes will talk in detail about our ATLs and how they were developed and how we use them. And then after the advice is finalized, as a final step in the advisory development process, we develop an advisory package, which includes a report, a fact sheet, and then posters in at least English and Spanish. Wes showed you a tour of our website. All of our advisories are found at this link, I think, which Anna also put in the chat. We have tons of information, as he showed you, related to our fish advisories, as well as the protocols that we've developed, including our prioritization process, which I'll talk about a little bit later on. And now we'll get into the first two steps, which are sampling and analysis. And we'll kick off this section with a poll. If you eat seafood, you probably have a favorite. So we'd love to hear if you have a favorite that's listed here. Our options are salmon, black bass, which includes largemouth, smallmouth, spotted, and red eye, sunfish, catfish, carp, shellfish. If your favorite isn't listed here, you can pick other. And if anybody wants to share what their other is, we'd love to hear it. If anybody wants to share how they like to cook fish, we'd love to hear that too.
My brains were working when I was creating this poll. You can pick multiples if you'd like. A bunch of you have already submitted, so don't worry about it. But yeah, we've got, everyone has responded. So I'm going to end the poll and share, and just note, flagging for folks that aren't live with us. Other things that are coming up in the chat are rainbow trout as something that's a favorite. And so we've got 80% of folks that completed the poll. Their favorite fish is salmon. Not surprising, delicious. And then everything else is the other. So salmon and trout are very popular for folks with us today.
Yeah, not a surprising result. So we have salmon in about 11% of our advisories. We have black bass in about 75% of our advisories. And then sunfish, catfish, and carp are all right about 50%. So anybody want to share how they like to cook their salmon or their trout? I'm boring, I just saute.
Well, since we have in part a tribal audience, I'll just say that that the canned fish after it's been smoked is my favorite. And I recognize that that's not something that agencies are always thinking about, but that's one of my favorites.
Yeah.
Thanks, Jerry. All right, we'll move along. So in 2022, OEHHA published a protocol which provides sampling and analysis recommendations to anybody planning on collecting data to be used in a fish advisory, particularly for local agencies or organizations that don't have an established sampling program already. Our protocol was written from our perspective and for this very specific purpose, but to anyone interested in collecting this type of data, we'd recommend also consulting the latest swamp and US EPA sampling and analysis plans for more detailed information. In our protocol, we discuss target water bodies, species, analytes, sample collection, handling, documentation and preparation, and then also chemical analysis and submission of data. So there's a few reasons to prioritize specific water bodies. In general, we would encourage samplers to collect enough data so that an advisory could be developed. This could mean getting enough data at a water body that's never been sampled, or getting enough of the data that are needed to supplement what we already have. We often consult with the STU on this, and we're always able and willing to work with samplers to help determine what the data needs may be, if there's any data gaps for a given water body. We would recommend specific water bodies for sampling based on metrics such as very high fishing pressure, or those of particular interest to tribes or subsistence fishers, if that information is brought to our attention. We may also be interested in water bodies that are close to pollution sources or water bodies in areas that have high CalEnviro screen scores. CalEnviro screen is a tool that was developed here at OEHHA to help identify California communities that are disproportionately burdened with pollution. And I'll talk a little bit later on about how we use CalEnviro screen. Water bodies with limited sampling that have shown to have high contamination levels may also be prioritized. And we also suggest targeting water bodies where low contamination is expected so that we can point to safer options for eating fish. And then similarly to how water bodies are targeted, we'd encourage for species to be targeted in a way that would enable us to develop a new advisory or add a species to an existing advisory. Species can be targeted based on tribal, recreational, or subsistence importance. In the past, we've focused mostly on sport fish, but our current practice is to offer advice for every species for which we have enough data. We may also target species known to be higher in contamination, such as black bass, to know what the highest concentrations would likely be in a water body. And we may also target fish known to be lower in contamination, especially those that have high levels of omega-3 fatty acids, such as everybody's favorite, the rainbow trout, to provide a healthier alternative. But in general, it's good to collect at least one predatory and one bottom feeding species due to the propensity to accumulate contaminants. Longer lived predatory species like black bass in freshwater or rockfish in marine waters tend to accumulate higher levels of mercury. And bottom feeding fish like catfish and carp or croakers in saltwater are known to take up organic contaminants and can also accumulate high levels of mercury as they age. So only species which are open and legal to take should be collected so that they're representative of what people are catching and eating. And Wes showed a version of this slide earlier, describing analyte sources. Target analytes can be any of the chemicals for which OEHHA has developed ATLs. We have ATLs for mercury, selenium, PCBs, PBDs, and several legacy pesticides. As he mentioned earlier, the chemical that results in the most restrictive advice for a species in a water body is called our risk driver. And again, it's possible to have more than one risk driver in a water body because different species accumulate chemicals differently. And therefore, the chemical that drives advice for one species might not drive advice for another species. Mercury and PCBs are the risk drivers at most water bodies. For that reason, mercury is almost always analyzed. PCB analyses are expensive and might not be necessary for all species sampled unless there's a known issue. So it's generally recommended for them to be analyzed in at least one representative species, preferably a bottom feeder, again, like carp or catfish. PCBs can accumulate in sediments. And if PCBs are low in those indicator species, it's not likely necessary to have to test in any other species from that water body. Selenium is rarely a risk driver and typically just in water bodies kind of in and around the Imperial County area. PBDEs are very rarely a risk driver, I think only in one advisory. And because their use has been phased out and levels in fish have generally declined, they're typically no longer analyzed for fish advisory purposes. And the same is true for legacy pesticides, whose concentrations have been decreasing in fish tissue. So these chemicals aren't commonly tested unless previous sampling has shown there to be an issue or a problem is expected for whatever reason. Ideally, the timing, I'm off, aren't I? Let's go back. Ideally, the timing of sampling would be planned for a time of year when fishing pressure is the greatest for the targeted species. If organics are going to be analyzed, one consideration would be to aim for a period when the lipid concentrations in the fish tend to be the highest, which would correlate with when you would expect the concentrations of organic chemicals to be the highest, so typically like August to October. And I'll get more into the sample size in a slide or two, but In small to medium sized water bodies, we would generally require at least 3 species and at least 9 individuals of a species to develop an advisory. And for species that don't grow large, including shellfish, it may take several individuals to get an adequately sized sample for analysis. CDFW has set legal size limits for certain species. Those may differ between water bodies, so you want to make sure that you're checking the current regulations before you sample. And that's just to make sure that you're collecting what other people are legally catching and eating. For species that don't have minimum legal sizes, like Wes mentioned, we have determined minimum edible sizes, which are based on their length at maturity. There's some exceptions, but we generally don't include any fish below legal or edible sizes in our advisories. And that's because there's an established correlation between fish size and mercury concentrations, and including any undersized fish could underestimate potential mercury exposure. There's a few considerations when selecting where to sample in a water body. We'd recommend choosing a site where people tend to go and fish. You could also focus on areas where there's a known or potential point source of contamination to hopefully capture the highest levels of contamination within the water body. And we've developed a guideline for helping samplers determine how many sites to sample based on water body type and size. So this is our table. It shows the recommended minimum number of sampling locations and the minimum number of individuals per species by water body type and size. So the recommended minimum number of sampling locations for lakes and reservoirs is 1 for smaller sized water bodies, 2 locations for medium sized water bodies, and then ranges from 2 to 4 for larger water bodies. The number of sampling sites recommended for rivers and creeks is at least 1 for every 25-mile segment. And that can be influenced by certain river characteristics, such as fish passage restrictions at dams. For bays and estuaries, the number of sampling locations is more of a case-by-case scenario due to a number of factors like size and tides. And then for the open coast, we recommend sampling from at least 3 or more CDFW commercial fishing blocks. And those are 10 by 10 nautical miles in size. They cover the whole California coast and are there to help fishers report their catches. The number of coastal locations sampled can also depend on the range of species. So if a species has a smaller range, we may require fewer sampling sites, and then vice versa. And for smaller size lakes or reservoirs, again, we generally require at least 9 individuals per species. For medium-sized water bodies with 2 or more sampling locations, we'd recommend sampling at least 10 individuals, with the numbers kind of split between those 2 sites. And then for the largest water bodies, we'd recommend 10 to 20 individuals split between 2 to 4 sites. For relatively short rivers and creeks, a minimum of 9 individuals per species is recommended. And then as rivers get longer, the number of sites should increase, and then the numbers of individuals per segment can decrease. For the coast, we'd recommend 10 individuals per block. And again, those are generally the minimums that we would prefer. The more data, the better, always. And any additional samples would increase confidence in the results. So fish can be collected by a variety of methods depending on the species and the habitat, but commonly include electrofishing, seining, trawls, hook and line, nets, and following a predetermined and practiced standard operating procedure will help you to collect samples that are free from contamination that you may encounter in the field, which can come from a variety of sources, such as your sampling gear, boat grease, engine exhaust. Polypropylene and polyethylene surfaces might contaminate samples to be analyzed for organics, and those should be avoided. And then samples should be handled with disposable nitrile gloves that are then changed between samples. Once samples have been collected, they should be identified by an expert and measured in the field. Weight and total length should be recorded for any species that has an established minimum legal or edible size. If total length is recorded in the field, each fish should be uniquely identified with an individually labeled bag, so that the sample can be easily matched with the chemistry results. And all individual samples from each collection site should be packaged according to their SOP, but typically they're wrapped in foil and double bagged, and the label can be stuck between the two bags to help keep it dry. And then those sealed bags with labels and completed chain of custody forms should be taken to the laboratory on wet or dry ice. All your field sampling forms should be filled out along with any photo documentation that you took. It's a good idea to take pictures of the samples in case the species ID is later called into question, which has happened. Photos of samples with scales may also be useful. And your samples should be chilled to about 6 degrees within 24 hours. And then that temperature should be held until they get to the lab. And there's a lot of great resources out there on proper sampling techniques. I've linked one here to the SWAMP's bioaccumulation monitoring program quality assurance project plan, which is a mouthful. So I would suggest you reference that one for more information. So one thing to consider when analyzing samples is if you want to do individual or composite samples. A composite sample is a sample that has an equal amount of tissue from multiple fish that are homogenized or mixed together before they're analyzed. Analyzing samples as individuals is best because it can provide an understanding of the range of contaminant levels among individuals. So this allows us the possibility of providing size-based advice, which we have done on a few occasions. An example of that is our Folsom Lake Advisory, which includes size-based advice for rainbow trout because of the difference in mercury concentrations between the larger and smaller fish. We've also based advice on maximum mercury concentrations in a species, particularly if several samples have concentrations that exceed our ATL limits for no consumption. So we don't have that level of refined data when samples are analyzed as composites. Composite samples, though, are much less expensive and are typically done for analytes other than mercury, and typically 5 individuals or so per composite. A couple of things to think about if you're running composites. Having each one made up of similarly sized individuals is nice to be able to better compare across size groups. So if you have 15 fish of varying lengths, you'd group your 5 smallest, 5 medium, and then 5 largest. Also, if you're making composites of fish that have legal or edible sizes established for those species, it's best not to include any undersized fish in those, as we may not be able to use those data. And finfish should generally be prepared as skin off fillets. There are some exceptions, and we understand that the information people want to get from the data may vary, so you'll tailor those to what you're looking to get out of the data. The soft tissues of bivalves should be analyzed, and then only the body, leg, or tail meat of crustaceans should be analyzed. The skin, the fat, and the viscera of fish and shellfish are known to have higher levels of organic contaminants like PCBs than the meat does. And our messaging to all consumers is to remove those parts before they cook and to eat only the meat. Small species, such as sardines, have no established minimum legal or edible size and are typically eaten whole by people, can be prepared as whole bodies, or they can be prepared gutted with head and tail removed, just to be more representative of what people are eating. And samples should be processed, analyzed, and stored by a certified and approved lab. And once the data are received back from the laboratory and they've been QC'd, ideally they would be entered into CDN which again is open source and can be accessed by anybody. There's some specific reporting requirements for submitting into CEDN, which are provided on their website. This table shows the minimum information that we at OEHHA would need to include the data in a fish advisory. And I'll just pause here for a minute and before I move on to the next section, see if anybody has any questions. We're going to go through one more section on data analysis and how we prioritize water bodies for advisory, and then we'll take a little break before Wes gets into the more technical aspects of ETL development. If you have any questions, feel free to pipe up.
Can we pop the that SFEI's QAP into the chat? I know we'll see the slides later, but that seems like a good tool.
Yeah, thanks, Sherry.
I'll add that link.
Thank you.
One question I had was, earlier we were talking about contaminants that people are worried about, and PFAS and 6-PPD quinone came up, but I didn't see those on the list of ATL, like contaminants that you have ATLs for. Can you speak to what's going on there and where you are with those?
Yeah, I think Wes is going to talk a little bit about that a little bit later on in his presentation. Yeah, we know that PFAS are a hot topic and on lots of people's minds, and they are also on our minds, and we are in the process of ATL development, but I'll let Wes speak to that a little bit more later on. Thanks, Anna.
Yeah, and just for 6-PPD quinone, it's been pretty well established that that's definitely toxic to salmon and some species. The effects on humans are kind of a newer area. We do have some work going on in that area, but it's very preliminary. So.
Thanks, Wes. All right,
Yep.
well, we'll keep it moving unless anybody has anything else. Going once, going twice. All right. So in this section, I'm going to briefly review our process for analyzing data. And this is just meant to be an introduction to our methods. It's going to be a lot of information, but if anybody wants more detail, we are always willing to go over this process one-on-one. So our first step is to populate the data. Again, our primary data source is CEDN. We'll also use any other known data sets that are not in CEDN if they meet our data criteria. So in CEDN, we click on tissue. You can also pull data by water body, county, water board region, or analyte. There's lots of ways to filter the data as well. Those are the ones that we typically use. Another way to access swamp-specific data is through the Swamp Data Portal, which I think there was a training on in another session. And then that link is here also. The only thing to keep in mind is that those won't include data external to the SWAMP program. It's SWAMP data only. And once we have all the data downloaded, there's a few steps to refine the data. We'll remove any analytes that don't have ATLs or any species not of interest. Occasionally, we'll get a data set that has tissue samples from species not of interest, such as birds or snails. Those get deleted. Sometimes older data sets in CEDN won't have associated length data for the samples. And in those instances, we'll use original data sets if we have them to fill in the lengths. And if any lengths are reported in fork length, which a lot of the older studies can be, we'll use a species-specific conversion factor to convert them to total length. We remove any fish that don't meet our minimum legal or edible sizes, as well as any duplicate samples. We typically don't use any organics data from before 2000 due to a change in how they were analyzed. Occasionally, a sample result will be reported in dry weight, and those will be need to be converted to wet weight, which our analyses are based on. And we'll also remove any fish that are analyzed whole, except in specific circumstances, again, such as for small species, or again, if that's how the species is typically consumed, we can perhaps analyze the data that way. And if data are abundant throughout several decades, that's great. We'll also compare to see if mercury levels have changed over time and if newer samples would warrant advice that would differ from what we would see in the older samples. Once a data set is refined, we'll organize the data by species and analyte. To calculate the table that you see here, which we include in our reports, we'll sum the total number of fish and samples for each species. We'll calculate the weighted average for total length and the chemical concentration, and we'll record those ranges. And then we'll summarize by species group. For example, largemouth and smallmouth bass data would be averaged to find a black bass result. And then we'll use our ATLs and best scientific judgment with a close review of all the data and as a whole to determine our consumption advice. And once all the data are summarized, we'll write and publish a report, a fact sheet, and posters in both English and Spanish on our website. We can also develop posters in other languages as appropriate for the area that the water body is in. So most of our statewide advisories are in about a dozen languages. We'll publicize new advisories on our social media pages, through press releases to local news outlets, through our email list, which you can subscribe to on our website. And we'll also notify relevant federal, state, and local agencies directly, as well as the water body owners and operators. And if you want to be added to this list, we could. And finally, our posters should be physically posted at the water body, ideally near areas where people are fishing. So this leads us, I think, to our last poll. What outreach methods are best for your tribal community? So we have all the things I mentioned here. We have our website, social media, press release, email list, posted sign. And then more importantly, if you have any other ideas on how we can get our message out more effectively to your community, we'd be super interested in having that conversation.
We've got, I'll leave it open for another couple seconds. Okay, and it looks like this was a multiple choice, but when they go back and forth, it's hard to remember. So someone said in the chat that signage is really important as well, like posting the signs. And it looks like a mixed bag of what's effective. And what I'm getting from this is that we need to spread the word in multiple different avenues to really reach folks. But we've got, close to 70% of the folks that responded to the poll thought that social media, press release, and email lists were among the most effective methods. And then after that, around 30% is the posted sign or other methods. For folks that said other, would you be willing to share your wisdom with us so that we can consider using that method to get the word out, or partnering with folks if that makes sense? And if not, that's okay too.
This is Sherry. I'll say a couple, which might spur people's excitement about talking about their others. What we've done in the past, C has done a lot of, we partner with the tribes to table at community events. So we provide trainings directly to tribes and to the doctors and nurses at Indian health clinics, and then those folks can become advocates at those tabling events. Tribal newsletters, you can fold in the advisories that are local for your area, and then it's an opportunity to put in the names of your species of fish. So people might call them different things, and we've actually worked with a couple different tribes that made their own handouts, and we worked. We took the advisories that are there and then made little tweaks to them so that it's applicable to individuals. Like, for example, there's different kinds of, like I talked about, a type of way of eating a fish that might not have been included in some of the advisories that are out there. There's just different ways of making the information come from the community directly. There's that, and I'll stop.
So, thanks, Sherry.
Thanks. Yeah, we're totally open to working with tribes if people want us to come and give talks on fish advisories. You know, I don't want to speak for Wes, but I think we'd be open, you know, to that. And feel free to reach out to us individually too if you have other ideas. We are definitely interested in any ways that we have to share our message. I'm stoked to see social media ranked high because I write our very goofy social media posts, usually with a really dorky pun or two. And it takes a while to come up with them. So I'm glad that somebody's appreciating them. All right, so we'll move on. All right. And last, I'm going to talk about how we prioritize water bodies for advisory development. So on a roughly annual basis, we'll go through and evaluate all available fish tissue data. We identify all of the water bodies that have enough data to develop a new advisory or when we can update an existing advisory. And then we'll prioritize those water bodies using both a quantitative ranking system along with some qualitative considerations. So each water body is assigned a score based on 4 categories. We have fish contamination levels, Allen-Barrow screen percentile, the distance to the closest water body with an advisory, and then the number of species that could be included in an advisory. So each category is assigned a score with low given 0 points, medium given 1 point, and high assigned 2 points. So for the contamination level metric, number 1 that you see here, a water body would get a score based on the average level of species contamination. So only mercury and PCBs are used in this analysis because, as mentioned before, other contaminants really drive advice and wouldn't have much impact on this scoring matrix. So if mercury is at or below 399 parts per billion or PCBs are at or below 42, the water body is given a score of 0. If mercury is between 400 and 439 or PCBs are between 43 and 119, a water body is given a score of 1. And then if mercury is at or over 440 or PCBs are at or over 120, which correlate to our do not consume levels for ATLs, a water body is given a score of 2, ranking it as the highest priority for that category. Black bass often have levels over 440, which is our cutoff to advise no consumption of a species for the sensitive population. So this highest priority is only given if a non-black bass species has a concentration over their values. So we aren't ranking so many water bodies higher just based on black bass. Also, our statewide lakes and our statewide rivers advisories both have do not consume for black bass for the sensitive population. So we kind of feel like those are covered there. And then the second metric is the Allen-Barrow screen percentile of the surrounding area of the water body. So again, Allen-Barrow screen is a tool that assigns a percentile to census tracts based on pollution burden of that area. So we'll identify the water body of interest on the Allen-Barrow screen map, which lists the percentile, and then we compare that value to our scoring matrix. So if a water body is adjacent to more than one census tract and the Allen-Barrow screen scores differ, we'll use the higher value in our scoring matrix. And for rivers that may cover many census tracts, the Allen-Barrow screen that corresponds to most of the river portions within the advisory boundaries is used. So if the Allen-Barrow screen percentile is between 1 and 24, we'll assign it a score of 0, assuming that the pollution burden is low. If it's between 25 and 49, we'll assign a score of 1. And then if it's 50 or over, we'll assign a score of 2, making it the highest priority for that category. Did it again. And then the third metric used is the distance to from that lake or reservoir to another water body with an advisory. Scores are applied based on the estimated driving travel time in hours. So water bodies with do not consume advice for all species are not included in this calculation because the intention of this category is to provide people with close regional alternatives. And rivers are excluded from this scoring category because they can extend over large distances in comparison to lakes and reservoirs, which makes it a very difficult analysis. So as you can see, if it's under an hour to another advisory water body, it's ranked 0. If another advisory water body is 1 to 2 hours away, it's ranked 1. And if there's no other advisory water body within 2 hours, it's ranked with the highest priority. And then our last metric is the number of species for which advice can be offered. A water body gets the highest score at 2 points if advice can be offered for 3 or more popular fishing species, or if it's a trout lake with 2 species, because they typically have fewer species of fish in them. And a water body would get a score of 1 if the 3rd species is smaller fish of lesser interest, such as a silver side or a golden shiner. And then the sum of the individual scores for the 4 categories provides the total score that's then used to rank the water body in order of priority. So total scores range from 0 to 8 for lakes and reservoirs, and 0 to 6 for rivers, again, because they don't include that distance score. The higher scores indicate a higher priority for advisory development. And since we redo this analysis pretty much every year, the priority status of water bodies can change as we get additional data. So we've talked about the quantitative factors at the top, which help us to prioritize water bodies for new advisories. But they can also be prioritized based on lots of other qualitative factors. These include fishing pressure, stakeholder requests, geographic diversity. Also, water body might receive a higher priority when advice is expected to be significantly different in comparison to our statewide advice or even nearby site-specific advisories. And reasons to update an existing advisory include if we can add a species, or if an advisory is based on data that were collected over a decade ago and we have some newer data available, particularly if it results in a change of advice for a species. It could be prioritized if it's an older site-specific advisory and doesn't have a detailed report. We have several of these still on our website that we're trying to create reports for. Also, it could be updated if there's been changes in the CDFW fishing regulations. For example, we just updated our advisory for Lower Puda Creek, in part because trout became no longer legal to take. So all that being said, does anybody have any questions? Again, I know this is kind of a lot to throw at you in a short period of time, but Wes and I are always available to answer questions one-on-one, go through data, explain our processes. We're here, we're available. We're ready and willing to chat anytime. But if you have any questions now, we'd love to discuss.
Not a question, but I just wanted to flag that in the past, when we've had tribal partners, part of the safety work group conversations, talking about their priorities, y'all are really listening when folks say, no, this water body is really, really important to us, or this species is really, really important to us, and can substantially modify your priorities accordingly. So just because it's on the long list of qualitative options, like there's real power in reaching out to OEHHA partners. I think Clear Lake is a great example of that. Are we on the same?
Yeah, my brain was gonna go there if you didn't, so you go there.
Yeah, I'll start and you can add it. But tribes in Clear Lake really wanted to add more species that were really important for tribal consumption, and they worked with OEHHA. They did collections. And the advisory was updated. So I just wanted to really flag that tribes have a lot of sway and power in this conversation, if that's a conversation you want to be a part of. And I'll pass the baton to you, Sherry, if you want to add anything else.
I was just going to say Sarah Ryan had a huge hand in working with OEHHA on that. And she couldn't be here with us today, but a lot of you know her and she's been in other slides. but Sarah and other presentations we've had as part of the series. And she, I'm sure, would be able to help you if you reached out to her. But definitely you saw a ton of traditional species in the Clear Lake advisory that we had never seen in any of the other advisories in the state. Oh, also, we've reached out directly to San Francisco Estuary Institute and to Fish and Wildlife when they were doing sampling, and they were able to add things pretty quickly to their list of sampling um, um, locations. So,
And Swamp has also done that in the past with in terms of determining our priorities as well. So, you know, you got lots of potential partners out here waiting to work with you.
Yeah, and I also wanted to echo something that Sherry said, that if various tribes are interested in developing more culturally appropriate language, working through SIA is a great partner that helps us translate our information to something that is more usable to a community. So we really look for those kind of community-based organizations and local partners
and
to make communication as appropriate as possible.
And what SIA likes to do, I mentioned, is, and we're going to talk about this in a minute, is we do an Eating Fish Safely training. And the goal is to make sure that the environmental directors and the staff people with all of you as tribes are the experts. So we would go out in the field with you if you like and help you to provide the information. And then once you're comfortable, we back away because we're hoping that this is something you're going to carry forward in your own community.
Thanks so much for adding those. I'll also say we have our list of potential advisories that we could do every year. And we present those to the stew, which is open. I think if people want to join those sessions and give their input, you know, we have more water bodies on those lists than we could possibly do in a year. So if you look at our list and you have a priority on that list, hearing your feedback would bump that up the list. And even outside that avenue, if you want to get in touch with us, we'd be happy to share a list and we can talk about priorities that you might have also. So the more feedback, the better.
I think I saw a sneak peek of the next slide, which is our break time. Is that should we start that?
Coffee break, water
Yes.
break.
Yes.
All right. Well, thanks, everybody. We'll head off to break and then we will hear Wes talk about ATL development afterwards. So get your coffee.
All right. And I think we have time for 15 minutes still. Is that good?
Yeah.
Okay. So it's a weird number, but come back at 10:32 and we'll get started again. Thanks, y'all. Awesome. Welcome back, y'all. We're going to keep it moving. Take it away.
All right. Thanks, Anna. Hopefully you're well caffeinated up and rested. I apologize in advance. I'm gonna throw some math at you. Thankfully, these will be recorded and always free to contact Lauren or I in the future for clarification or questions or concerns. So I just want to add that disclosure beforehand. So I'll get started with discussing how we develop our advisory tissue levels. And another resource is on our webpage. These two documents are available. They're not light reading, but I am more than happy to answer questions or direct folks to specific areas if they want additional information. So you've seen this slide a few times. It's just the background of what ATLs are. And again, things to keep in mind is that we use 8-ounce servings, and some of the ways we include health benefits. I'll show you how we do that on a quantitative level or by using the equations. These again aren't like hard thresholds, but they're guideposts that help us in developing our advisories. And they can be based on cancer and non-cancer health effects. And I'll walk through, there's different equations for each of those. So I'll walk through both of those. And one of our guest star, I'll turn it over to Sherry. to present this slide that is beautifully done from the SIA Eating Fish Safely pamphlet.
You might need to unmute.
Hopefully Sherry is back from break.
Yes. We've been chatting. I'm gonna see if I can use my Zoomy host powers. I'm gonna ask Sherry to unmute. I actually don't know what that does on your end, like on the other person's end. But... We were having some technical difficulties earlier this morning too.
Yeah.
Maybe these are really important slides and I want Sherry to be able to present them. It looks like she's jumped off.
Yeah.
Or dropped and is probably going to try and come back on. Maybe let's get started and then we can end with these and she can
Okay.
kind of add that contextual lens after all the mathy bits.
Sure, that works.
But we'll circle back to these for sure.
Yeah, so there's great information in these pamphlets. Just some additional information. Eating fish is known to be good for the cardiovascular system, and it can lower the risk of abnormal heartbeats, lower triglyceride levels, slow atherosclerosis, as well as lowering blood pressure. And these are very high level, I'm not going into any details on the health effects. And one of the most important aspects of fish consumption is the omega-3 fatty acids and the effect it has on infant health and infant health outcomes. And this is just a quote from the last set of the US FDA EPA guidelines, that eating 8 ounces of fish per week is important for improved health outcomes due to DHA, which is one of the omega-3 fatty acids. Additionally, the federal recommendations are, again, to consume 8 ounces per week, with the caveat that younger children eat less, and women who are pregnant should eat 8 and up to 12 ounces a week of fish that are lower in methylmercury. And some of the fish that are recommended not to be eaten are shark, swordfish, tilefish. There we go. There's Sherry. Big eye tuna, orange roughy, and king mackerel, and marlin. So those are some of the highest fish in mercury. They can reach upwards to 2 parts per million. So again, you've seen this slide multiple times, so I'm sure you're familiar with it. And I won't go through it again, but I just want to point out that I will focus on mercury as a case study to walk through the slide, through the equations and how we develop our ATLs. And then here's another slide for Sherry once we get through our technical difficulties. So I'll start moving on.
I'm back, but I can do my slides at the end if you'd like. I don't know what the other one was.
Oh, I can back up quickly. We didn't miss it by much.
Oh, okay. So sorry,
Yeah.
people.
Oh, no problem.
So I'll be quick. So one of the things is that these advisories that the ATLs that Wes is going through really developed for the health trainings that we were talking about. And the reason why this is so important is that there's over 300 symptoms to mercury in the human body. And so doctors don't screen, your primary care physician's not screening for it. So what we did was gave presentations for doctors, nurses, with clinicians and communities, and specifically the tribal environmental department, because we wanted to ask the questions, do you eat fish, from where, and how much? And then the numerical equations that Wes is working in really come into play. And if the doctors have a training, after a training, they can risk whether or not that patient would be high, need to um, have their blood tested for mercury, because really, if you go through the symptoms, you may not arrive at the endpoint of mercury. It's very rare that would show that. Um, so the importance of eating fish has already been discussed by Wes, said that that's important because fish are really good for you, but they're really essential to the development of your brain and your heart and your nervous system, especially for a developing fetus. We really want to make sure that that people don't stop eating fish. We really want to message things in such a way where we're saying fish are, if someone tells you they're eating a very high mercury fish, we would say, so glad that you're eating fish. Fish is such an important part of your diet. And then steer them towards the advisories and steer them towards the species that are better for them, or the locations that are nearby, which is why earlier Lauren was talking about, the other water bodies in their area. So that's part of that messaging that's so important. So what we were thinking is that we can get into the mercury in the human body training in 2025. But this really, what we're talking about today, really links into the tribal beneficial use work that we do. And it really helps us to, for tribes and for us as environmental advocates and self-advocates, to start to see how the numerical pieces of fish tie in to water quality objectives later. So with that, I will stop. Let's go back to what you were saying.
Thanks. And
But I will
that's
say that vegetarian sources are not the same as the omega-3 fatty acid chain that you get in fish. You can't really avoid eating fish if you want those really high fatty acids that helps with brain development of developing fetus.
yeah. And if we want to get in, thank you, Sherry. If we want to get into the physiological reasons for that, it's another talk. So I just had this other slide, Sherry, that you kind of already hit on. I think you hit the high points of this, but
We'll do a
Sherry,
deeper dive in 2025. I
yeah,
think we could schedule this kind of a training, but it leads into the whys of the numbers that Wes and Lauren are talking about today.
yeah, that's great. Because really it is, like Sherry said, the developing fetus and young children that are most at risk. So where does mercury come from? Most of you probably already know this background, but mercury is a natural element. It's typically high in the coastal range of California, and a lot of mercury was mined there that was used during the gold rush and subsequently released into the environment in a lot of Central Valley rivers, and also some of the mining that was resulted in releases to water bodies such as Clear Lake. It's also released into the air through the burning of coal, and that mercury that's released deposits on the landscape. Mercury is present in probably all fish throughout the world to varying degrees. And then mercury, inorganic mercury, is not generally as toxic as the methyl mercury that's produced by bacteria and accumulates in fish up the food chain. So fish consumption is the major source of mercury, and general US consumption of fish does not put people at risk, but for populations that consume high quantities of fish, there's more concern. And that's where it's really important for groups like SIA and other cultural groups to educate their communities on fish consumption to make sure they're not seeing those effects of mercury, because once you're seeing symptoms, you generally have a much higher load within the body. Unfortunately, you can't see or taste mercury, so there's no way to really tell without testing. And then, as Lauren discussed, mercury tends to be highest in older predatory species like largemouth bass, striped bass. And that's why some of the tuna and marlin and sharks are so high, because they're eating all the smaller fish. And even some marine mammals can accumulate levels of mercury depending on their diets. So like I just mentioned, most mercury in fish is methyl mercury. It is analyzed as mercury because it's much cheaper. And because the amount of methylmercury is like 90%, we just assume it's all methylmercury. And again, methylmercury is more toxic. There's actually an even more toxic version called dimethylmercury, which can cross the skin. And there was a story that it killed one of the world's leading experts in mercury. She was a Dartmouth researcher, and it crossed through her gloved hand and resulted in her death sometime later, which is incredibly tragic. Mercury is concentrated in the fillet and the muscle tissue and can't be removed by cooking or cleaning, as some of the organic contaminants can be, which I'll discuss when I discuss equation development. So how do we know that mercury can cause health problems from fish consumption? There was a tragic case in Japan in which mercury-laden wastewater was dumped into Minamata Bay. The mercury accumulated in the fish, and there was actually a disease called Minamata disease that affected almost 2,300 patients. And this level of exposure was drastically higher than would be the case for most people. And that's why it served as an example that some of the studies are based on, and a lot of the toxicity information was from this study, as well as a poisoning in Iraq. It's interesting to think as close as 1970, people were coating seeds with mercury to try and prevent mold growth. And unfortunately, some of those seeds that were treated with mercury ended up in being used to create bread in Iraq, and resulted in 6,500 cases of poisoning, along with 460 deaths. So these are very high levels of mercury, but provided the basis for a lot of our understanding of the toxic effects of high levels of mercury. So as we've previously discussed, we learned that the nervous system and the brain are some of the target organisms or organs of mercury poisoning, and high levels will result in mental confusion, loss of balance, irritability, fine tremors, numbness and tingling, changes in vision. And like Sherry mentioned, these are pretty general symptoms. So it's difficult from a clinical perspective for a doctor to identify mercury poisoning without knowing that a person is consuming high levels of fish or is exposed in some other way. And even more important, that the fetus is sensitive to mercury, as the mercury can travel from the placenta through the umbilical cord into the fetus. And as the fetus is developing and the nervous system is going through rapid development, the mercury can interfere with the normal development of the nervous system. And children are also more sensitive to the effects of mercury. There's a saying in toxicology that children are not little adults, that when toxicology was first being developed, it was just assumed that kids were just lower the body weight and then you can have an equal understanding. But now there's an understanding of the increased sensitivity of children and babies and developing fetuses. So there's usually extra protection put around these populations. So again, the effects occur at much lower exposure levels in the fetus and children.
Can I add one quick thing?
Yes.
It is that part of the reason why women are in those charts as being lower of course the main driver is the babies in utero, but also the fact that women everyone accumulates methylmercury in the body, and it stays there for over a year. So this is why when we give advice to women, we're saying that women need to follow the advice for mercury in fish for a year becoming pregnant. And for women, especially traditional women, California Indian women, and women who eat fish like that, traditional people do, is that that means that we have to be careful, because you don't want to avoid eating fish for your entire year of your life and not passing on that to the children. So it's a cultural issue as well. And so this is why we really get into like the pieces on what we want. We want to be able to tell you to eat fish. We want to be able to tell you where to be able to go. So that's why these are so important.
Yeah, thank you, Sherry. Yeah, and it's really a fine line of not scaring people from eating fish, but making sure they're eating the right fish. And it's kind of a delicate balance at times. And that's why it's so useful to have community partners to develop that information. So how do we set safe levels of mercury exposure? And this is done by looking at populations who consume, well-documented populations that consume lots of fish from the Faroe Islands, the Seychelles Islands, as well as New Zealand. And they were able to identify some of the lowest doses associated with adverse effects. So in the Faroe Islands, mercury exposure occurs through whale and fish consumption. And average mercury concentrations in hair were more than 20 times higher than the average US resident or citizen. And hair is generally used as an indicator as well as blood, but hair is a better marker of long-term exposure and is much less invasive. And interestingly, there are no effects seen on the mothers, but effects were seen in children using sophisticated testing. There were noted effects in attention, fine motor function, some of the visual system, and also memory. So it really shows that mercury affects all aspects of brain development. And again, just reiterating that these were much higher maternal hair concentrations than the US average. But again, the US average isn't consistent across the board, and there are certain populations that may consume fish into the levels associated with these different studies. So how do we use this information to set safe exposure levels? The equations we look at take into account chemical toxicity, and I'll discuss those values for both cancer and non-cancer, the amount of exposure that's estimated in terms of a consumption rate, and meal frequency and meal size. And we also use body weight to normalize the levels of exposure. And so here's our first math. So I'm going to start off with the non-cancer equation because it's a bit simpler than the cancer equation. And you can see some of the different variables that go into the equation. So what I'll do is just walk through each of these step by step, starting with the body weight. So again, this is a body weight assumption for people across California. So we're not focused on one specific population. If someone was interested in focusing on a certain subpopulation, then they might choose to use a different body weight. But it's recognized that the human body weight changes over life stages and across sexes. Typically, we use a body weight of 70 kilograms or 154 pounds for both men and women. Other government agencies such as the US EPA use 80 kilograms for certain programs. Again, risk assessment is usually based on the exposure scenario at hand, so the values may be different and tailored to the specific assessment. And then moving on to the consumption rate. In the consumption rate here, I guess, can be interpreted differently in that we're not looking at how much a specific population eats in trying to determine what the risk is. We're using a meal frequency to set thresholds in the forms of the ATLs to provide advice. So sometimes we say we're doing sort of a backwards risk assessment to provide that advice. So we use meal frequency of 1 to 7 servings, and each of those servings are 8 ounces uncooked. And that is equivalent to 224 grams, and that can be represented by 32 grams per day. And the US FDA and EPA use serving sizes of 4 ounces, but based on research from the California Department of Public Health, we decided to go with 8 ounces because our research showed that fish consumers tend to eat more than the average US citizen. So again, using that 32 grams per day. Then moving on to the cooking reduction factor. So like I previously mentioned, PCBs and other organic contaminants tend to accumulate in the adipose or fat tissue in fish. So by cooking and allowing juices to drain away, that reduces the levels of those contaminants. Unfortunately, sometimes the benefits of the fatty acids are washed away, and sometimes the fat is some of the best part. But that is just something that we take into account. Again, mercury and selenium are generally in the muscle or fillet tissue, so that is not reduced by cooking. And for organic contaminants, we'll use a cooking reduction factor of 0.7 to account for that 30% loss. Skinning can also reduce levels of organic contaminants further. So there's that value. And then the toxicity value is really known as the reference dose. And the technical definition of the reference dose is an estimate of daily exposure to a chemical that is likely to be without significant risk of adverse effects during a lifetime. And what that really means is if you're exposed to a level below the reference dose, then we wouldn't expect someone to experience the health effects. And generally, the RFDs will include sensitive individuals, such as elderly, pregnant women, children, or other identified sort of characteristics that would make them extra sensitive. And certain risk assessments will use different factors or uncertainty factors to account for that sensitivity. So OEHHA uses the US EPA RFDs. For the sensitive population, we use an RFD of 1 × 10⁻⁴ milligrams per kilogram per day. And that was from the research in the studies I previously mentioned, the Faroe Islands and the Seychelles. And this was a more advanced risk assessment or dose response assessment that was done versus the RFD for the general population of 3 × 10⁻⁴ milligrams per kilogram per day used a less sensitive, what's known as a NOAEL, low-AL approach, which is the no observed adverse effect level or low observed adverse effect level. And I won't get into that level, but that's part of the risk assessment equation that is known as dose response assessment. And that would be another whole course altogether. That would be more than 8 hours, probably. So we have that value and I'll focus on the value for the sensitive population for the purposes of this talk. So we can start plugging the body weight in. We can add our RFD. And then our cooking reduction factor doesn't apply in this equation because we're talking about mercury. And then looking at the consumption rate of 32 grams per day. And this is, again, where things take a turn and get a little more complicated. So when we're evaluating the risks and benefits, we use what's called an average hazard quotient to incorporate benefits. And it relies on a modified consumption rate. And it's only used for 1 to 2 meals per week because the majority of health benefits are really realized at 2 meals per week. So it's not, we don't want to encourage consumption and hence further exposure beyond levels that are going to provide health benefits. And then another equation, the hazard quotient is the exposure over the RFD. So it's just a ratio of those two things. And this is kind of usually the hazard quotient is set at 1. And if it goes up to 1.5 or so, then the exposure needs to be lowered. But what we do to incorporate benefits is use a hazard quotient of 2 and 1.5. That way we're allowing a little exposure, but knowing that some of the positive and beneficial effects of fish cancel out some of those adverse effects. And then over time, because generally people don't eat the same fish from the same water body, and fish as people who have measured fish tissue levels, it can vary widely. So we use that average hazard quotient concept. And I apologize for any headaches. Just another disclaimer. So another way to think about this is if we look at what the consumption rates would be across the different frequency categories, it would just be a straight line in essence. So it just double each time. You have 32 grams per day, 64. And that's what we'd use for a hazard quotient of 1. But by adjusting the hazard quotient of 2 and 1.5, we do that by lowering the consumption rate to 16 grams per day for 1 meal per week and down to 48 grams per day for 2 meals per week. So that way we allow a little extra exposure, knowing that the benefits of fish will likely outweigh those negative consequences. And this is the full drawn out equation. Again, if we were to use 32 milligrams per day, our cutoff for no consumption would be 220 parts per billion. And this is the same value we use in numbers that are known as our fish contaminant goals. So that's purely a risk-based number. And that can be used for cleanup values, and it's listed in our equations or in those documents for the ATLs. But like we've talked about previously, and Sherry's also mentioned, that we really want to encourage fish consumption. So by changing, essentially having that consumption rate per day, we end up with a higher cutoff or ATL value for no consumption. And this value is still fairly conservative compared to other values used nationwide. So when we look at the modified consumption rates, looking at 16, 48, and then again, meal frequencies beyond 2 meals per week, just use a straight hazard quotient of 1. And you can see the values here. These are the exact equations we use to derive our ATLs. And these are the upper level cutoffs. And here's our ATL table here. So you can see 440 is the cutoff for no consumption. 150 to 440 is the range for 1 meal per week. 70 to 150 is the range for 2 meals per week. And then greater than 55 to 70 is the range for 3 meals per week. And then in general, the sensitive population is about 3 times higher, and that's due solely to the RFD. And another complication. So chemicals don't play nicely. They tend to accumulate, multiple chemicals accumulate in the same individual fish. So we do assess this for certain specific scenarios where the chemicals have the same adverse endpoint on the same system. So we look at this for the developing nervous system in fetuses and young children, and this is only employed for mercury DDTs and PCBs. So if any one or all of these or if 2 or all of these chemicals are together in the same individual, in the same species, it may result in offering fewer servings per week, so the advice is more restrictive. And this is assuming that the toxicity of these chemicals is additive. And this is done by using what's known as a hazard index approach. It's basically adding up the hazard quotients. And this is only used for non-cancer. So before I go there, are there any questions, concerns, or thoughts? It's kind of a lot of concepts that kind of pile up and I know make me my brain hurt a little bit.
And just wanting to reiterate and flag too, all of this is being recorded. These slides will be available. So if you want to come back and review something later, and if you're feeling like your eyes are glazing over and you're not absorbing anything that's being said, that's totally fine. Everything will be available after the fact. So that's I think why we I requested that Wes go into a lot of detail here so that it can be a reference moving forward. So I'm a little bit to blame for some of this.
And it's okay because it does come into play as we talk about tribal beneficial uses. How much of a human body it's that 145-pound is a pregnant woman's size. It's like they're looking at the most at-risk person and coming up with a number. And then there are websites or there's ways of putting in your actual body weight to see if you can eat more or less fish. So this can become as personal as you need it to, but we do use it for setting water quality objectives and for safety for fish consumption.
Yeah, thank you for that. And yeah, these are we're looking over the population of California, and these equations can be tailored for specific situations or exposure scenarios. And to Anna's point that a lot of people's eyes glaze over, and this is a great way to, if you suffer from insomnia, sometimes listening to this information, I've spent a better portion of my life learning a lot of this stuff. So yeah, it takes a while. And I'm always available if you want to reach out and have questions. So moving on to cancer. Cancer gets even more complicated than non-cancer. I won't go into deriving go into actually using numbers in this equation. Determination of the cancer slope factor is a very complicated process that we still have ongoing trainings, and it's an ever evolving discipline. But this will give you a brief overview to hopefully have some insight into what these words mean and how they interact to come up with these levels. So another long definition, the cancer slope factor is an upper bound estimate of the probability, so that's risk, that an individual will develop cancer over a lifetime as a consequence of exposure to a given dose of a specific carcinogen. So this is usually developing a cancer slope factor, or a potency factor is another word that's used. There's a lot of modeling involved in different computational programs. And in essence, it means it's your risk of getting cancer over a lifetime of exposure. And another thing that's important to understand is we assume no threshold. So in non-cancer, the assumption is you can be exposed below a certain level, aka the RFD, and you won't have adverse effects. Whereas carcinogens, from the lowest level of exposure, there's a risk of cancer developing, because cancer is such a complex biological process. But on the other hand, it's a stochastic process. So that means that just because you're exposed, it doesn't guarantee that you will develop cancer. The body has a lot of mechanisms and ways to prevent cancer from developing. The idea is just to not overly inundate the body with carcinogenic exposure. And again, cancer development is a whole nother thing. So the times that we look at in the form of exposure duration and averaging time. Again, this is an equation that's using factors tailored toward a wide population. So 30 years is assumed to be the exposure duration based on the 95th percentile of US residence time. And this may not be fully representative of tribal individuals who maybe live at the same spot for a good portion of their life. So if different exposure scenarios are of interest, then that factor can be modified. And then an average lifetime of 70 years is assumed, and this is a typical value for risk assessment. Again, if you're focusing in on a certain population, this can be adjusted. But our charge as a OEHHA is to develop advice statewide. So we use those more general assumptions. And the risk level is something that we use to balance the benefits and risks. So in the US EPA produces a 4-volume guidance on development of fish advisories, everything from similar to this training, how to do sampling and analysis, all the way to risk communication and risk management. In that, they recommend a risk level of 1 cancer case in 10,000, all the way up to 1 cancer case in 1 million. And it's generally recognized that 1 cancer case in 1 million is the background level that happens even without exposure. So that's the value that's used in our fish contaminant goals. But because we include benefits, we use a cancer risk of 1 in 10,000, assuming that the benefits of fish consumption will help outweigh the risks. So that is the cancer equation. And this is a table of all the ATLs that we have developed to date. And the highlighted areas are the contaminants that have cancer endpoints. And DDT is a little quirky because we use a cancer endpoint at the 1 meal per week, and then it shifts over to non-cancer as being the most sensitive level above that. So again, this table is in our ATL document if you'd like to look at it further, and will also be on the slide deck and this presentation recording. So what's in the future? And Anna asked this question about PFAS. There was just a week-long workshop out of the Great Lakes looking at PFAS, and it's just a rapidly evolving area. And I'm sure most of you have heard about PFAS. They are known as forever chemicals. Unfortunately, they're the fluorine carbon bond is one that is not generally broken down in nature, so they tend to stay around forever. But they're very useful chemicals, and they're used in a wide variety of commercial and industrial processes, everything from waterproofing materials all the way to the firefighting foams and the AAAF. PFAS accumulate in fish. Again, that's one of the common things that we tend to that characterizes the chemicals we look at. They're found in fish worldwide and humans worldwide in blood levels for humans. The PFAS don't follow some of the trends for size and age, as Lauren discussed with mercury. Mercury tends to follow a certain relationship with size and age, and then PCBs tend to accumulate in certain species that are typically bottom feeders. PFAS don't play by those rules, so we are reading up on the literature on that and looking at some of the great data that Anna and SFEI are pulling forth. And we are currently working on an ATL for PFOS, which is the most common PFAS that is found in fish. It represents about 75% of the total PFAS load. And it's just interesting as we go through the research. There's the newer analytical techniques to measure PFAS look at about 40 chemicals, but it's known that there are hundreds to tens of thousands PFAS. So it's something we're really trying to wrap our brains around. And it is challenging for not just the fish consumption community, but also water quality, air exposure. So it's a very prominent topic in toxicology these days. So that's about it. I would like to thank the water board, the state water board, and the STU especially. We are dependent on a lot of their data to develop these advisories. It composes about greater than 90% of the data we use, and also regional boards for providing local information and additional sampling, and also the Department of Fish and Wildlife. Also Moss Landing Marine Labs and the San Francisco Estuary Institute, Jay Davis at the helm. And again, thank you to Anna and Sherry for providing their valuable insight and help in developing this presentation and slide deck. And then this is Lauren and I's contact information. So feel free to email us at any time. And with that, happy to try to answer any questions or have a discussion regarding any of these topics.
Go ahead, Sherry.
I don't have a question. I just on there just in case anyone has anything I can help with.
Get out of my brain this morning. We're like in the same wavelength.
We've just done these trainings a few times. So I recognize, hello, Chloe and Anira and Israel. I recognize you guys, and especially, and I appreciate you sticking around. Do you guys have any questions about how this relates to TBUs, or does it seem to the mathematical equations and all of it seem to align with kind of your understanding? Do you have any questions? Are we still recording? Should we pause?
Yeah, I was just gonna say that we can pause the recording if you all feel more comfortable speaking up, and that way it's not included on the internets. Just let me know what you need, and we might. I do have some next step slides.
Oh yeah.
So let's do those, and then we can pause the recording and come back to broader discussion.
That's great.
Great. That way people can think about questions and discussion that they have as well. One thing I wanted to flag that I didn't actually include on these slides in terms of PFAS data, California, the Bioaccumulation Monitoring Program, we haven't collected PFAS data until recently. And I'm happy to report that we just shipped yesterday, I think over 100 of our archive samples to our chemistry lab going back many years, sometimes 5 or more years to get those tissue samples analyzed for PFAS, so that we'll be able to have a little bit of a historical record of PFAS and places that we've already collected samples through our statewide monitoring program. So that data will be coming in. Announcements will be shared on the safety work group as they start to come in. And Wes and Lauren are already, it takes some time to get those analyzed, but they're ready and waiting for those data to include in their ATL process. That was just fun. We got the notice yesterday that they're shipped, so that's really exciting. In terms of the training series, if y'all have been with us before, you know that if you registered and or attended this training, I'm going to be spamming your inbox, hopefully in the next couple of hours, with links to the recording and these slides. And it takes a couple more days before that can be posted on our website, but you will be the first to know when stuff is available. And I'm also going to include, just like I have in the past, any links that were shared in the chat. I'm going to add those to a slide at the end of the slide deck, so you'll have those as well. Another thing to flag for the training series, and the next day or so, I'm also going to email anyone that registered for a training over the past year to complete a survey to tell us like what you thought, how it went, what resources you might have used during or after a training, and what you'd like to see next. So Sherry, I think, mentioned another training about, TBUs and advisories and things like that. We have things in our brains about what we think might be helpful, but hearing directly from you, people that have used this resource, on what else you want to see from us, that would be really helpful. So just heads up that survey, I'm sorry, my brain just like stopped. That survey will be going out in the next week or so, and there won't be a deadline to complete it. So at your leisure, you can complete it. Next slide, Wes, please.
Yeah, if I can figure it out, I was trying to figure out reactions. Oh,
okay. And there's also some backup slides.
yeah, sorry. Were you talking about the adaptive management?
Yeah, no. I just wanted to make sure I covered everything. That was it for next steps. So I'm going to pause the recording so we can have a freer conversation. So anyone on the internet, thanks for joining. See you next time. And I'm just going to pause.